Morning everyone. My topic for presentation is graph theory. So first we will discuss what is graph. So a graph G is mathematical structure consisting of two sets V and E, where V is the non-empty set of vertices and E is the non-empty set of edges. So here you can see that these are the V1 and V2 are the vertices and E1 is the edge of these. And here also the E1, E2, E3, E4, E5 and E6 all are vertices, and E1, E2, V1, V2, V3, V4 and V5 are the vertices. These are the given examples. So now we will discuss basic terminology. So a trivial graph consisting of only one vertex and no edge is called trivial graph. Here you can see it is given that only one vertex and no edge is given. So a graph consisting of n vertices and no edges is called a null graph. Next is directed graph. A graph consists of the direction of the edges then this is called a directed graph. Here you can see that the graph the direction of E1, E2, E3 and E4 all are given, so it is a directed graph. Next is undirected graph. So a graph in which direction is not it is not directed, then it is called an undirected graph. Next is self loop in a graph. So if a edge having the same vertex as its end vertex, then it is called a loop graph. So here as you can see that the starting vertex and end vertex both are V1, so it will be a self loop graph. Next is proper edge. An edge which is not self loop is called a proper edge. Next is multi edge. A graph consisting of two or more edges having identical end is called multi edge graph. So here you can see that all the edges E1, E2 and E3 they all are having the common vertex that is V1 and V2, so these are multi edge graph. Next is simple graph. So a graph does not contain any self loop or multi edge is called a simple graph. Next and here example is also given. This is an example of simple graph. Next is multi-graph. So a graph does not contain any self loop but contain multi-edge is called a multi-graph. Here the example is given that in this graph we can see that this is V3 is the edge of it has multi edge like E4, E5 and E2, E3 all are the edges of this graph, but it does not have the self loop. And next is pseudo graph. So a graph contain both self loop and multi edge is called a pseudo graph. So here you can see that it has a self loop as well, but as well as multi edges. So this is an example of pseudo graph. So incidence and adjacency. Let Ex be an edge joining the two vertex Vi and Vj. Then Ex is said to be incident of Vi and Vj. So two vertices are said to be adjacent if there exists an edge joining the vertices. So here the example of it is given, where here we can see that E1 is the incidence of V1 and V2, and V2 and V2 are adjacent of V3 and V4 are not adjacent. Next is degree of vector. So a degree of vector V in a graph G can be written as d of V is equals to the number of edges which are incident on the V with the self loop. So here we can see that in the given example we can see that the degree of V1 is 2, V2 is 4, V3 is 2, V4 is again 3 and V5 is 2, V6 is 2, V7 is 0 and V5 is 0. V8 is 0. So next is isolated vertex and pendant vertex. A vertex having 0 is called isolated vertex, and a vertex having degree 1 is called a pendant vertex. So these are two other degree 0 and degree 1 vertex are called as isolated and pendant vertex. Next is finite and infinite graph. So a graph with finite number of vertices as well as edge is called a finite graph, otherwise it is called an infinite graph. So which means if all its vertex have the same number of degree, then it is called a finite, and otherwise it is called an infinite. So here in the example as well we can see this is an example of finite, so that here the vertex can be seen, degree of the vertex can be defined and it is finite number, so it is a finite graph. And in this we cannot define the degree because it keeps on increasing again and again, so it is an example of infinite graph. So that's it from my presentation. Thank you.